Bismillahirrahmanirrahim. Today I will talk about the experimental side of diode. And our purpose was to determine the properties of the diode semiconductor, and we explain what is the semiconductor and what is the p-n junction to produce all of the diode, the transistor, the lid, and at last the solar cell. All of these, to produce all of these, the main simple device is the p-n junction, is produced from silicon or germanium. Today we will talk about the diode. We have two terminals in each diode. Let me show you this. The gray one, this side, it's the cathode, the minus, the negative terminal, and the black side, it's the anode, the positive terminal. To determine the properties of this diode, actually this diode, depending on from which element is made, in some simple voltage like 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, no current we will have according to this ammeter. The result will be 0. That's according to the depletion region between N and P sides. This depletion region will act as a wall, will prevent any current from through inside it. At 0.7, because this diode is made from silicon, not germanium. If that's from germanium, the voltage, the starting voltage to act on the depletion region, to make the depletion region let some electrons through from it, will be less than the silicon diode. Let me come back to our topic here. At 0.7, some electrons will through from the depletion region, just some simple amount of electrons. We will have simple reading, we will have a simple value of electrons here, and we will calculate that together. This will be the VF. What that means, the forward different potential of this diode. I mean, the voltage will force the depletion region to make some electrons through from it. The starting voltage to have electrons, this is the VF to this diode. Let me repeat that. That will be according to this diode is made from which element, silicon or germanium. Now, according to the circuit, this is the key. Let me open it. Ammeter with series connection, power supply or battery, DC electric source. After that, my diode, here the cathode, anode. After that to the R state, and come back to the key. I put this to make the idea of increasing or decreasing the R state is clear. By the maximum value of this R state, this bulb will be at maximum with maximum current. At minimum of this R state, we will have the less value of current. By that, this bulb will shows that to us. Let me close this key by this way and start. Like I said, 0.1, 0.2, 0.3, 4, 5, 6, all of that will be, we have different potential according to this voltmeter, but no current. Okay, the result of current will be 0. but at 0.7 here maximum R state, that's mean the minimum current will flow from the circuit, because these have inverse relation between them. 0.7, let me check it. Yes, it's great. 0.7 current. I have just dot 0.2 ampere. Let me increase the voltage a little bit. Let me check. It's 0.8. Now I have more than 0.5, more than, yes, let me say 0.1 ampere. That's mean the current value is increased from 0.002 to be 0.1. That's mean it's multiple 5 times. Now let's work on 0.9 or 0.85. Let me open this key and change the power supply or the DC electric power source with bigger. Here the different potential to this battery is 6 volts, and let me try. Okay, let me change the terminals. Let me check this. The digital voltmeter is better. .55. At 0.55 it's more than 0.2. It's 0.28 at 50 at dot 58 volts. I have current equal 0.28. Now at 0.9 I have approximately 1 ampere. That's mean the bulb is clear here, maximum, minimum. By that we can prove why this diode is used as multiplier of voltage, electric voltage, because by increasing just 2 millivolt or to just 0.2 volt, we increase the current from 0.02 to be 1 ampere by just adding 0.2 volts. We have a huge increasing. By that, the relation between current and voltmeter will be exponential relation. Your plot will be as a curve. By that we explained why this voltage, and prove that why it's using as a voltage multiplier. That's it.